Very good morning to one and all. This class, let us discuss about this mesh analysis. In this mesh analysis, look at the circuit given in this slide. There are three mesh is there in the given circuit. First, you must understand the difference between the mesh and the loop. In this, there are three meshes are there. This is mesh number 1, mesh number 2, mesh number 3. The mesh currents are represented with I1, I2, I3 respectively. Most closed path in any circuit is called as the mesh. For example, this 1 ohm, 13 volt, 4 ohm constitute a closed path. There is no other inner circuit is there, so you can call this one as a mesh. Similarly, 4 ohm, 2 ohm, this 2 ohm, these three constitute a mesh. Similarly, 2 ohm, 0.5 ohm, 1 volt, these three constitute a mesh. Definition for loop is any closed path you can call it as a loop. For example, all mesh here you can call it as a loop, but the reverse is not true. All loop we cannot call it as a mesh. For example, here three mesh, mesh 1, mesh 2, mesh 3. All three mesh I can call it as a loop. In addition to that, few more closed paths are there. Outer closed path. I mean 1 ohm, 2 ohm, 0.5 ohm, 1 volt, 13 volt constitute a closed path. This also we can call it as a loop. This one, I mean 1 volt, 1 ohm, 2 ohm, this 2 ohm and this 13 volt constitute a closed path. This also we can call it as a loop. This one 4 ohm, 2 ohm, 0.5 ohm, 1 volt constitute a closed path. This also we can call as a loop. So the Kirchhoff's voltage law you can apply to any closed path. It may be a mesh or loop. That is not a matter. So for this circuit, you have to compute the mesh currents. That is the first question. Number 2 is determine the total power loss in the circuit resistors. There are 5 resistors are connected in this circuit. 2 voltage sources are given, 13 volt and 1 volt. Find the power associated with the voltage sources. This 13 volt and 1 volt and the total power supplied by them. So we are going to see all the questions. First, you can assume your own direction for the mesh currents. I have assumed I1, I2, I3. I1, I2 anti-clockwise. I3 I have assumed clockwise. So it is your wish. You can assume your own directions. Finally, we will be getting same answer. The three mesh equations obtained like this. I1, this I1 plus 13 plus 4 I1 minus I2, because this 4 ohm resistance, both the currents are opposing each other, right? This current flows like this current comes towards like this. So both the currents are opposing each other. As far as this 4 ohm is concerned, it is a common branch. So I1 minus I2. That is 5I1 minus 4I2 is equal to minus 13. This current starts from this negative plate. So that I have mentioned here minus 13. If you assume in this way, it starts from positive plate, you can substitute 13. So this is the equation number. This is very simple. In the same way, you can write the other mesh equations. Finally, we'll be writing the matrix equation like this. This one is delta. This one is I1 matrix. This one is voltage matrix. Look at the values of minus 13, 0, minus 1. So this minus 13 is depends on the direction which you are assuming from the current from the voltage. If the current starts from the positive plate and reaches negative plate, you can substitute plus 13, as I have assumed from negative plate to positive plate. So I have substituted here minus 13. This V1 is nothing but summation of the voltages connected in the first mesh. This V2 is nothing but summation of the voltages in the second mesh. V3 is nothing but summation of the voltages in the third mesh. So this is sometimes this can be represented as E1, E2, E3. So this was generalized matrix form R11, R12 and so on R1n. So usually we will be getting either 2 mesh circuit or 3 mesh circuit, not more than that. The generalized matrix equation R into I is equal to V or E. So again here R11, look at the diagonal elements R11, R22, R33. are always positive. It is nothing but the summation of the first mesh resistance, summation of the second mesh resistance 8, summation of the third mesh resistance is 2.5. This 5 is summation of the first mesh resistance. So all the diagonal values always positive irrespective of the current direction which you are assuming, whether it is clockwise or anti-clockwise. Look at the off diagonal elements, minus 4, 0 to upper half, the lower half minus 4 to 0. This upper half and the lower half element values depends on the current direction which you are assuming. For example, here R12, this one is R12, resistance connected between the first mesh and second mesh. If both the currents are coming towards the resistance, you can substitute positive value as the current I1 and I2, mesh currents I1 and I2, both are opposing. Here it is minus 4. Look at this, there is no resistance connected between 1 and 3, so that this is 0. Same way, if R13 is 0, R31 also should be 0. If R12 is minus 4, R21 also should be same, minus 4. R23 is 2, R32 also 2. So this way you have to fill up the resistance matrix. I told you already how to fill up the voltage matrix. So if you solve these values of the mesh currents I1, I2, I3, you will be getting I1 is minus 5 ampere, I2 is minus 3 ampere, I3 is 2 ampere. So now come to the question. Total power loss is 25, 16, 8, 18, 2 plus 2. So this is nothing but total power loss in the resistances. You know already the resistance, you know already the mesh currents. So based on the mesh current, you can calculate the voltage drop in all the 5 resistances which is connected in the circuit. So voltage drop is nothing but I into R. The power loss is nothing but I squared into R. So you can calculate, once you know the current, mesh current, you can easily calculate the branch current. Based on the branch current, you can easily calculate the voltage drop in that particular resistance or else power loss in the particular resistance. Here the power loss is calculated in all the 5 resistances. Their values are nothing but 25, 16, 18, 2 and 2. So you can sum up all the losses in the resistance. It is 63 watts. Power supplied by 13 volt battery. Power supplied, DC power is nothing but V into I. You know the current which is flowing through this battery, that is current I. You know the magnitude of the voltage battery 13. So it is 65 watt. 65 watts and 63 watts. Where is 2 watts? It is to be noted that in 1 volt battery, in the right side, positive current leaves the negative terminal. Therefore, the power received by 1 volt battery, it is 2 watts. So here, one uh, battery source, that is 13 volt battery source, is uh, supplying power. Another battery, that is 1 volt, which is mentioned in the right side, is receives the power. It is charging. So it is to be noted that 1 volt battery's positive current leaves the negative terminals. Therefore, the power received by 1 battery is 2 watts. Alternatively, we can state that the power supplied by 1 volt battery is minus 2 watts. It is very simple. If you represent the current in any resistance 5 ampere plus 5 ampere like this, the same, if you reverse the direction this way, you can write minus 5 ampere. In the same way, you can represent the power here as 1 volt battery supplies minus 2 watts. So the total power supplied by the battery is already I have mentioned here is 13 volt batteries releases 65 watts. So this 1 volt battery charges the 2 watts. So total power supplied by the battery is 63, right? So thus 13 volt battery is discharging mode, whereas 1 volt battery is in the charging mode. Fine. Thank you.